Hello all. Welcome to week 2 of the 2021 Hot Water Forum. My name is Amruta Khanolkar and I'm from New Buildings Institute. I will be moderating today's plenary panel. The plenary topic is Carrot and Sticks in Hot Water Forum, the heat pump water heater policy and programs rodeo. In first 30 minutes of the plenary, all the presenters will give an overview of Advanced Water Heating Initiative and different efforts under the initiative. And the last 30 minutes will be an interactive panel discussion with question and answer. Let me start with a few housekeeping announcements. As a reminder, your screen is customizable utilizing the various widgets found at the bottom of your screen. Presentations can be downloaded as PDFs from the resource list in the menu. Attendees are in listen-only mode, but can submit questions and suggestions through the question and answer box anytime during the webcast. Presenters will be answering questions following all the presentations. All the presentations will be available for on-demand viewing within few days on the Engagement Hub. ACEEE would appreciate your feedback regarding this year's Hot Water Forum, and you will have access to the survey link in all of this week's sessions in your console. Please take a moment after you watch your last webcast and complete the survey. For those who do that, you will receive $25 discount off of your registration for the 2022 Hot Water Forum in Atlanta. Last, we want to thank the sponsors and partners for their support for Hot Water Forum. With that, I wanted to introduce our panel. So we have Smita Gupta today. She is Director of Building Innovation at New Buildings Institute. Then we have Gary Klein. He is a president of Gary Klein Associates. Owen Howlett. He is a customer experience strategist at Sacramento Municipal Utility District. And Kashmira McVeigh, she's an emerging technologies program manager at Bonneville Power Administration. With that, I am going to introduce Smita. She's going to go over she'll be presenting on the magnitude of the opportunity and give an overview of Advanced Water Heating Initiative. I will hand it over to you, Smita.
Thanks, Amrita. And hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. As Amrita said, I'm Smita Gupta, Director of Building Innovation at New Buildings Institute. And we've been talking about the hot water, but in this forum, but specifically the heat pump water heater is the focus of our plenary today. And, while I don't have to tell this group about, what the opportunity that really is, but want to emphasize a few, points about the magnitude of the opportunity available with heat pump water heaters. I think this Bloomberg article, title says it best in terms of, where you can call your water heater a secret weapon in climate change, really sort of has the ring to it, how much more effective can you get in terms of the PR and the marketing towards a market transformation program. And so, and really, if you come down to numbers, the magnitude of the opportunity that there is, in the US homes, water heating by fuel type, really represents, 54% is fossil fuel dominated. So there's the potential for moving that to heat pump and decarbonizing that. And if you talk about the commercial sector, it's also in the 40+% range, between natural gas, propane, and fuel oils. And the building stock, as you can see in the large numbers represented here, is like, in hundreds of millions of homes and 4 million commercial buildings. To put some, big numbers in terms of the magnitude, there are 27 million households with water heaters that are over 10 years old. Again, the potential to swap all of them out for more carbon-friendly heat pump water heaters. There is around 8 million water heaters replaced annually. Again, an opportunity to move those to heat pumps. 2 million almost water heaters that are installed in new homes annually. And 30 million is the potential, the capacity of the market to really, be able to install heat pump water heaters. What does that convert to carbon emissions? That represents almost a gigaton of carbon emission reduction saved in a year. And to put it into perspective, that's like taking out 26 coal-fired power plants. And even if you compare heat pumps to what we've come to know as a very clean generation, distributed solar that has matured over in the last decade and a half, heat pump water heaters really stack up well against those as well. 3 times more cost savings, 10 times more energy saving, and 3 times more carbon saving annually compared to, this is all the distributed solar in 2020 in a year alone. So again, the magnitudes are really there. And add to that the demand response potential, which is taking out the dirty peaker power production that's needed. So with controls added, the heat pump water heater again have the potential to add another 20 to 40 gigawatts of demand response potential. And if you, this is an analysis done by my colleagues at NBI, which represents that the heat pump water heater compared to other traditional water heating types, the electric and the standard gas and tankless, the carbon emissions are low. And to focus more here is the operational cost when you add this demand or the control element. Even the operating cost is way lower than the tankless water heaters. And the equity and the energy burden, they address that as well, and add the kind of scale, not just in cost, but the carbon reduction. Having established that magnitude, I'll cover the overview of the Advanced Water Heating Initiative, which is an initiative started in the West Coast, the Pacific Northwest, and California, and has been operating over the last almost 2 years here, led by NBI, but along with our funders and partners, Bonneville Powers, Southern California Edison, NEA, SMUD, Building Decarb. You have the website link here and with the presentation, and you can visit there for more links. It represents over 50 organizations, the initiative, and has over 100 active members that represent across several different market actors in the industry. As you can see, the mix is manufacturers, utility participants, industry associates, and cities and program administrators. There are 5 key, it's primarily a market transformation initiative and focuses on 5 priorities. First one, of course, is the transforming the market to increase adoption and penetration of heat pump water heaters, along with focusing on new construction first, where the barriers to entry are relatively lower compared to a retrofit or a swap out, and building demand with more awareness through marketing campaigns, and creating uniform programs and incentives along with training and tools for a more holistic approach to transforming that market. The logic model or this construct of the water heating initiative is set up in terms of focusing on the key elements that you see on the top here, which is strategy, technology advancement, and then priming the market, and operates under these 4 channels, which are the next layer over of focusing on the actual technology, along with the regulatory programs and the market. It's operationalized through 4 working groups that are operating in over the last, again, almost 2 years. And in fact, you'll hear from my fellow panelists, Owen Howlett and Kashmira McVeigh, who lead 2 of these working groups. The working groups are focused on the unitary market, which is 240 volt and 120 volt, and central, and also a working group that's dedicated to moving the needle on the controls element of the heat pump water heater. There have been several successes and deliverables that have come out of the almost, as I said, 2 years of operation of the initiative. It started at an exposition and workshop at SMUD. There have been Title 24 has adopted demand management standards. There is the 120 volt units, which is one of the key things that has changed in the market for the heat pump water heater, especially the retrofit market, which avoids panel upgrades that are going to be hitting the market later this year. just in the short, time since the initiative started. There has been a lot of collaboration with local and regional state government agencies, along with utility programs. In fact, there is a progress report and a playbook that's available on the website link that was mentioned, and you can go ahead and download that from there, which provides a lot of the valuable information and the learning that has come out of this initiative. In 2021, the efforts are, to continue the West Coast initiative, but also expand it to more, at a national level. So expanding it to cover the entire country, and also focusing on other regions with their regional context and specific needs in different regions. The Midwest, where perhaps the disadvantaged communities and the equity issue is a bigger at play, to the Southeast, where it's the electric resistance water heaters that are more ripe for change out. There is since 120 volt is the new product on the market, there is planned a field study to validate and field verify these units that are hitting the market later this year. The central packaged units, that comes as skid system. I think Kashmira is going to talk more about that, along with the program engagement and training efforts. So I'll end with the overall vision for really the initiative is, as you see in this theoretical model, the green line representing that the vision is that by 2045, the entire stock of water heaters really gets changed to the high efficiency, low carbon heat pump water heaters, and coupled with the declining of the conventional water heaters in the market. So that's really the vision. And having spent over a decade in the California Solar Initiative, as that came of age, in terms of distributed solar or rooftop solar, as we now ubiquitously know that, the goal of the California Solar Initiative was to, install 3,000 megawatts of solar over 10 years. And through a focused initiative, that was not only possible, but exceeded that goal. But even at the end of the program, the market has continued adoption. So that's the kind of market transformation and success that we really need for the heat pump water heater. With that, I'll end my presentation. Back to you, Amrita.
Thank you, Smita. That was great. I am going to now hand it over to Gary. Gary, do you want to take it from here?
Yes, thank you very much. So I want to talk a little bit about the tensions between codes and incentives. I don't work directly on the heat pump, the Advanced Water Heating Initiative at the moment. I focus on the hot water as a system, and I want to spend a little bit of time looking at the way we go about our overall program activities. So I have some discussion points, and I hope they'll come back to us during our discussion later. The first one, I think we want great buildings. And my first question is, are we really getting them? And do you want to live in a production dwelling that is built according to regulatory and program rules you've been promulgated, or without any additional information? So I have an observation. I don't think we're getting great buildings. I think we get something that's probably, maybe it's a bit better than minimum code. But the question is minimum code great performance? No, not necessarily. And so I think we have to create an overall approach that gets to have great buildings. In the case of hot water, I want great hot water systems. I don't want just great water heaters. It all has to work together. Can we regulate great buildings? I don't know. Codes, even stretch codes, are the minimum we're allowed to build. Regulators think of codes as the floor, and the people who build think of them as the ceiling. Now, the observation is that codes are the first passing grades, and when I went to school, that was a D-. Do you want to live in a D- building? Because that's what we're building. Well, even if it's a high bar, because that's the way we've structured it, I don't think that's what our target has to be. I think our target has to be buildings that perform extremely well. And one of the observations I would make is, how does the person who actually does the work know they did their job correctly? Because in many respects, we expect the lowest paid person on the job site to be in charge of quality control. Because if they do their job correctly, it works well. And if they don't, they don't. And is the feedback they get timely and actionable? I want to tell a short story. When I was working in the weatherization programs in upstate New York back in the late 80s, we were teaching people about blower doors and infrared cameras. And they were very expensive to get back then. And so the agency would get a blower door and an infrared camera. And in the first year, the supervisor would show up at the job site, and in the morning with the crew would do the blower door test and do an infrared camera scan, show everybody what was wrong, and leave. 6, 7, 8 hours later, they'd return and they'd run the blower door test and they'd run the infrared camera again. And they'd say, "You missed all this stuff." Well, nothing got much better the first year. The second year, they had an extra blower door. And they put the blower door in with the crew got to keep it, who was doing the work. And every 20 minutes, they turn on the blower door and see what their work for the last 20 minutes had done. And they got much better feedback, more timely and more actionable. If the last 20 minutes didn't do any good, why would you keep doing it? So they learned what worked and what didn't. Their buildings got better much more quickly. They missed fewer things. They knew what to seal. And it's that kind of feedback we have to give workers on the job site to give us better work. In the plumbing world, the hot water world, I don't think I've seen a heat pump water heater or a gas water heater or a Purple Cow water heater installed correctly about 90% of the time. There's almost always something that's not done correctly. That's bizarre. We know how to put in water heaters, or we should. New water heaters, like heat pump water heaters, aren't exactly the same as the last, 20, 30, 40 years of standard efficiency gas and electric water heaters have been. Things are in slightly different spots. The plumbing is a little different. The connections have different requirements. It goes on and on and on. And we need to pay attention to it. We need to give people better feedback. Can you incent great buildings? Well, we appear to create a construction culture that expects to be paid for marginal cost for the higher performance. And I'd say that becomes an addiction for both the contractor and the regulators. We think we have to keep paying to get marginal cost. And it's a self-fulfilling prophecy. If you don't pay, they don't do it. Well, maybe we're paying for the wrong thing. I wonder what if the incentives actually went to create and sustain the feedback loops that we need so that the people doing the work know that they've done a good job, right? We want to have people do blower door tests on a building. We want people to make sure that the hot water system works correctly. We want to make sure that refrigerants are charged properly and the pressure drops on AC systems are done correctly. So we try to pay people for the marginal cost, but we don't make sure that the work's done right. We're not providing the feedback to the people who are doing the job, so they don't know that they're doing their job right. No one gets the feedback. Maybe we ought to help the process of getting great buildings by focusing our dollars not on marginal cost, certainly not at the beginning, but we should focus on the feedback loops. And why do we choose regulation over incentives? Well, those who do regulation may have a hammer, incentives have a screwdriver. I don't know. We can only see either nails or screws. Maybe we need to find a better way of balancing the approach. So we want to have great buildings by, let's just say, 2045 or 2050. Pick a number. It doesn't matter exactly when it is. And we have a combined approach that's clear from the beginning of how we're going to work on standards and how we're going to work on programs and how we're going to verify we're building the power plant we're trying to build in terms of megawatts or the carbon reductions in terms of mega units. But we have to do the verification and the feedback. And I think that we have to combine programs and incentives with regulation and make sure everyone knows where they're playing and keep that policy for a 10, 20-year period. With that, I'm done. Thank you.
Thank you, Gary. So that made me think. So just a reminder to our audience, we will be taking all the questions at the end of all the presentations, but please keep sending your questions as well as suggestions in the question and answer panel. With that, I want to hand it over to Owen, who will go over the unitary market demand building effort and the current utility program best practices. To you, Owen.
Okay, thanks, Amrita. So I can advance the slides, right? There we go. Okay, so today what I want to brief everybody on is the work that the Unitary Working Group of the Advanced Water Heater Initiative has been doing. And just to set the scene, this is kind of a coalition of the willing. This is 96 people who all self-identified at various different past forums and events, and who have stayed in contact. We organized a working group earlier in 2020, and through July 2020 to last month, we had 13 meetings of the full group to basically work our way toward a set of recommendations for market transformation for unitary water heaters, which means, you know, the storage tank water heaters with a heat pump on top. I think it includes Sandons as well, but basically this is mostly the single family market and the standalone water heaters. So what we've been working toward is a market transformation report, which has a whole set of recommendations for what should be done to make the market move forward. It is late in the day in terms of state and national greenhouse gas goals. So everything has to happen fast. So a lot of our recommendations and our work is based around how do we get stuff to happen fast? How do we get this market to transform quickly? So this report is intended to be super actionable. It's not a report that just states a bunch of stuff that you already know. It's a report that contains new things that many of which you will not have seen before. So I do recommend that you, if you're interested, you take a read, and you'll probably find some things there that you will be interested in and excited by. The report is mostly about programs, mostly about incentive programs, because at this stage of this technology, the technology is actually pretty mature and pretty good. And the main thing that we're focusing on is how do we get these good water heaters into people's homes? And that becomes a question of programs, and then how programs eventually feed into code, and when we make a good code based on our success. So the content of the report, let me go forward here. The content of the report really boils down to a whole set of actionable sections which set out things that utilities can do and manufacturers can do to create successful programs that will grow quickly. And so the place to start is number one here, program best practices. We already know quite a bit about what works because there are some successful programs. So what we've done in the report is distill a lot of the lessons from those successful programs, which we were told by the people who ran the programs. They told us what was successful and what wasn't, and how they succeeded. We've distilled that down into a set of actionable bullet points. That's the first step. The second step is okay. Once you've got a program that's kind of in line with best practices, the second step is how do you keep moving forward? And so we've got a whole section on how programs can use research and continuous data collection to inform constant iteration and constant improvement. And that's going to be a huge factor, because if we're going to get to the goals that we need to get to by 2030, 2040, then we need to learn really fast to reach the new markets and the new customer types that we need to reach. We do not yet know how to do this, so we have to build the ship as we are sailing it or flying it or whatever we're doing. And then the third part of the report is a whole bunch of what we're calling critical emerging issues, which will significantly affect the success of programs, and we recommend that program managers, program planners, and designers get their heads around. in order that your programs continue to grow and be successful. So the current best practices is the starting point. This is just an excerpt from the report. This is a logic model of how those existing programs have worked. So on the left there are all the things that you need to put in place. And then as we move toward the right in that diagram that's how these things result in the outcomes that we want. This is the logic of how these programs work. And then again, this is another excerpt from the report. This is a little graphic showing different cycles on which research can be used to inform program design. So you can have some very fast turnaround research cycles that inform quick decisions about the program, and then you have some longer cycles which are required for kind of longer stock taking, M&V, and program redesign. We've also recommended in the report some immediate goals. These are 3 to 5 year milestone goals, and the intent here is, and this is just for California utilities, so you can scale up and scale down, for different parts of the country. The point of these goals is, if we are going to get to 10% market penetration in 3 to 5 years, these numbers here represent roughly what that needs to look like, based on assumptions. The top table shows you the assumptions about what penetration rate we're getting to in each one of these sectors. And then the table at the bottom is how that translates to an actual number of water heaters that would be purchased and incentivized by programs. So this kind of shows you like roughly what's required for each utility, where each utility needs to get to in California to do their part of this market transformation. These do not represent goals that anybody has committed to. These are entirely suggested and voluntary at this point. So the report has recently been completed. This is, like I said, culmination of 7 or 8 months of work by a whole bunch of people of very different backgrounds. So we think it's a pretty good piece of work. I encourage you to download it at this link. It's pretty easy to find on the New Buildings website. This is going to be available as a PDF just for a week, only 1 week. So please download it as a PDF, put your comments in it, and then return it to me if you have any comments or thoughts about the report. We can still make changes if you want to see changes in the report to reflect various things. After this round of edits, it will be done, and it will be fully baked, and it will be available after that as a PDF. So if you would like to be involved in future, let me know, or you can sign up through the Advanced Water Heater Initiative website. Thank you.
Thank you, Owen. That was great. Moving on to our next presenter. So Kashmira will be going over the Central Heat Pump Water Heater Team's approach to accelerated market transformation. To you, Kashmira.
Okay, can you see me and hear me fine?
Yes.
Lovely. All right. So thank you, everyone, for joining us today. For the Central Heat Pump Water Heater Initiative, as part of the Advanced Water Heater Initiative, we have a pretty auspicious goal. We sat down last fall and decided our goal would be high-performance heat pump water heaters, central systems, will represent 90% of the products in new multifamily construction across the United States in the next 5 years. And we said, wow, that's pretty intense. So how do we want to reach that goal? And in order to reach that goal, we kind of scratched our head. We said, well, what tools do we have to do this type of mass accelerated market adoption? And how are we going to get there? And whose help are we going to need to make this happen? What's the easiest way to break down this problem and make it start working? And so we thought to ourselves, well, we need to have products that are competitively priced everywhere with the next best technology. We need to have performance in a plug-and-play type of system. We can't waste a lot of time and money and certainty on custom-engineered systems. We want things to be plug-and-play, low GWP. We want to see the performance measured as the entire system. We want to have multiple manufacturers in the market. We want known, quantifiable, repeatable savings. We want to be able to facilitate manufacturer engagement, and we want everyone in the market, from manufacturer to end user, supplier, distributor, designer, building owner, architect, engineer, to know about the product and want the product. And so we broke it up into 3 big chunks, as you see in this diagram. Basically, we have a price team, a products team, and a market transformation change management customer team under our initiative. And we said, let's take this drive, this energy that's in the market, and try to coordinate it amongst parallel paths. So we have jurisdictions developing a lot of policy, code, reach codes, and this was really developed for the California market, where we have this drive for code adoption in 2022. And we have a policy path. And at the bottom, we have the utilities being pressured to put new products into their programs. And so we have a utility path. And then on the green swim lane, we have the markets and how do we support our markets and our market support path. And then in the middle, we have is what we tend to do really well as emerging technology organizations. I think the slide is animated, and I think the animation is going to come up or not. Is really just focusing on the 2 areas of application testing and demonstration. Oh, there we go. And that seems to be what we tend to do well in most instances, but we're adding all these other layers going around at the same time. And the other aspect of that is that we're compressing what a timeline might be from 8 to 10 years, we think, by doing this, and bringing it down to maybe 2 years. So there's a lot more detail behind this, but our products team is really hoping to design plug-and-play systems. So we want to be able to create a sizing calculator, have a system developed, sized, put it on a skid, and have it drop shipped at a job site for new construction. And so we're hoping to see 7 new low GWP products, central heat pump water heater products, through our technology innovation model in the next 2 years. We'd also like to see the design guidelines that support 5 new systems. That's what we're hoping to do. We're also going to be creating additional research on temperature maintenance and thermal storage and DR. And we plan to have 3 projects in the next few years. And part 1 of our plug-and-play engineering design systems has been developed. That's the EcoSim, which can be found there. That link is available for anyone to use at any point in time. And that does the sizing for the system, so you can trade off between energy storage and system size. Our next part of that will be developing an energy modeling that'll do that, and that'll be called the EcoSim. Our price team includes the specifications, standards, a pro forma program that other utilities can lift and use, and code development, code tracking, code intervention, comments, etc. And right now they're working on and plan to wrap up by summer a system specification, an advanced water heater central system specification 8.0, which will include, if you can see in the diagram, what is the boundary? It's not just the compressor. So the compressor alone will not get us the energy savings we want, because when it's hooked up to that distribution system and the storage tanks and the mixing valves and all the other equipment in the fence line, we're going to start to see a degradation in overall system performance. And so they're developing that specification to address the system performance as a whole. In addition to that, as I said, they'll be working on a standard pro forma program that is based on the EcoSim and EcoSizer modeling. So they'll get a tiered incentive for using those tools and sizing the system accordingly and having it developed on a skid and then drop shipped to the site versus custom engineered. If it's a custom engineered where the tools aren't used and people are designing their own things, then we were going to offer a lesser incentive, because that's too hard for utility programs to oversee and administer those payments. Finally, on the customer side, I think in broadest terms, our goal is to have as I said before, everybody to know about the system, to want the system, to understand the system, have consistent terms and languages that are used in developing these systems, buying these systems, selling these systems, installing these systems, and operating these systems. So what we're doing, I think that's a little different than our traditional emerging tech approach, is that we are having those swim lanes again, whether it's the specification development and some initial training and the product development, all being done simultaneously, and using that common terminology, using that common learning, that common foundation all the way across all those swim lanes as we develop our program offerings and we're doing our demonstrations and engaging our stakeholders all along the way. And what's really fantastic is we have this platform that we've developed that offers in-person training all the way to asynchronous training, and hopefully in the future, kind of online bulletin board, real-time consulting support, all tied together that any utility can use, small or large, scaled appropriately, to provide people the foundations and tools that they need, whether it be an installer, a utility program, an end user, a design firm, et cetera, that provides them the information they need to be successful in installing these systems. And together with that three-prong approach, we're hoping to really make a difference and accelerate the transformation of this market. And that's all I have. Thank you.
Thank you, Kashmira. Some interesting work happening at the Central Working Group. And with that, I want to thank all of our presenters, and I would like to request them to switch on their cameras so that we can now move on to the more of a discussion and question and answer session. We have received some great questions from the audience, and I'm going to start with, so this question is for Owen and for Gary. So Jim is asking, and he wants to hear more on Owen's response to Gary's presentation. So basically, to expand on that, I would like to, in other words, how can programs and codes and standards work cohesively together to advance in market transformation?
Well, I mean, this is a question that can have a potentially very long answer, but I mean, the way I personally think of this is that programs and codes should do a good dance together. That if we want to get good codes, then we need good data to base those codes on. And where do we get that good data from on cost and energy performance? Well, we mostly get it from programs. So if we set up our programs to collect data in a really good way that can be shared and combined and added together, then we get codes more quickly, which is what we want, and we get codes that are more accurate, better pitched. But then that doesn't mean that the job of programs is then done ever, right? Because then once one code is written, we then have to think about what's the next code going to be and what's the next code going to be, and they need to be informed by programs too. So the whole thing is going to, I think, continuously evolve and ideally be a virtuous circle.
So, Owen, I wonder why we keep thinking we have to keep advancing the code. The code is the D-. It's the bare minimum we should be expecting to be built. Now, I want to live in a good building and I want to have good hot water systems, right? But every time we move the code up, we make it harder for people to comply. And what we want to do is to make it, I think, easier for them to comply better. Mm-hmm. I mean, I want to make it so obvious that you've done the right work that it's going to work well. Right? I mean, you've been working on programs for water heaters for a long time. We've been colleagues for many years, right? And we've had this conversation at some level. Well, it didn't go so good that time. Has installation gotten better? Has the practice of the doing of the work gotten better? What are we missing in making it all better?
Right. I mean, I think it depends on the time scale you look at. If you look at the previous code and the code before that, it's pretty easy to identify things that didn't go well right? Changes to the code that were poorly thought through, issues that just nobody anticipated, unintended consequences. But then I think if you take a longer view back further, I think the code becomes a virtuous thing, because if you look back to what people were doing in the 70s and 80s, homes were not being built well. And homes generally are performing much, much better today than they ever were. So ultimately, the intention really of a code is not to keep hammering people and saying, you must do this, you must do this. The intention of a code is to change conventional practice, right? To change the culture, so that when somebody comes to install a water heater in a home, they don't even think about installing a gas water heater or an electric resistance water heater. They just think about installing a heat pump water heater. And you take the bad options off the table and progressively over time. That's what I see the goal of being.
Thank you. My observation on this piece is that the system, the connections to the water heaters are still being almost ignored in terms of good performance and good practice. And a couple of examples that I think we need to bring into the mix, and I think that they really need to start as program activities as part of new construction, because that's the easiest way to teach stuff. If you don't, making it a requirement just makes everybody annoyed. Because they don't know what they're doing. And so I would observe that, as an example, we now have a method of doing a better job of right-sizing all of the piping in a building, both hot and cold. And the impact using this method, it's Appendix M from the Uniform Plumbing Code, which we're doing some work to try and get adopted ultimately for statewide use here in California. It's usable now as a code, but it's not statewide adopted yet. And what's interesting there is that if you use it, you roughly cut the volume in the building's plumbing system in half. That's the first order effect of right-sizing the plumbing. Well, that means the hot water system the volume got cut roughly in half, which means you've got a lot less energy to lose over the course of a day. Whether it's the piping that cools down after you're done with the events, and piping cools down after events, or if it's recirc loops in the central system. The piping is smaller, the heat loss is smaller. Well, we should be thinking about ways to incorporate that into good practice and ultimately explain how to do that as part of normal code. Make it part of the submittals that you have to show the plans and you have to show the Appendix M stuff. So I'm looking at the system effects, not just the equipment effects, and I think those still need a lot more work.
And I think
let's take another question.
That constant problem that you can't require good design in code, right? We've been trying to get parallel piping and things specified in code, and compact plumbing design specified in code forever. It's just super, super hard to do, because you can't write a code that covers all these possible permutations. Anyway.
I hate to break this great discussion that is happening, but there are many questions coming in, and I want to be judicious. So next question is for Kashmira. Phil Jordan is wanting to know the timeline for the EcoSim, and when will it be available, and will it be available for the public? And I would just expand to that. Like, can you also talk a little bit about the approach your working group is taking for accelerated market transformation?
Yes, thank you, Amrita. So the EcoSim, we're looking for funding for that right now. I think that the current funding estimate is about $300K. The EcoSizer, and it'll take 6 months to develop and pull together. It's almost ready to go. We're just waiting to launch with the money. The other thing is that the EcoSim, I just want to give a shout out to SCE and SMUD, because they were the ones that funded the first iteration of the EcoSizer last year, and we completed that work, and then now that's available for everybody to use. So my goal is to get that money soon, now, please send a check so we can develop it. Moving on to the next thing, the approach that we're taking, Amruta, to get to scale rapidly, again, is that plug and play approach. So what we're hoping with those tools that we put out there, the EcoSim and the EcoSizer, people will be able to design plug and play systems. We're also looking to the manufacturers to work with the skid manufacturers and have these products assembled on the skid. So they literally are developed and sent to the site completely ready to plug in. So that way we won't have multiple issues that we see with the risk of contractors or other designers not being familiar with the equipment and struggling with how to maybe install, commission, these products and get the performance and savings they hope to receive. And at the same time, reduce the costs. So what we see is people put in increased costs to cover the risk of unknown system operations. We hope to reduce that risk by offering these plug-and-play systems and building market confidence in that fashion. So, of course, people can still do their own, but we just won't incent that as much is our approach. Mm-hmm. Thank you.
Thank you, Kashmira. So the next question is for Smita. So you mentioned about the California initiative, the solar initiative. Can you expand a little bit on that and how you would be able to use your experience there on the advanced water heating initiative?
Thanks, Amrita. Yeah, I mean, today the success of distributed solar really does not need to be debated. But at the time that the California Solar Initiative was starting, there was, back in 2004, 2005 in California, it was the SB1, the Million Solar Roofs program, as it was called. I think the approach there for market transformation that really worked was taking a more holistic view of, coming at having this multi-pronged approach to the market. So not only was there incentives, the whole carrot and stick or the codes, while we were building solar requirement into the codes, there was also the aggressive incentive program, which was set up to, have volumetric triggers, which is essentially scaling down the incentive as there is more adoption. I mean, that's really at the heart of, a successful initiative or an incentive program, is that you catalyze the market for self-sustained growth, that, you don't want to have the market depend on incentives for its survival and life. So having the right incentives that truly, seed the market to take on the growth. And the successes, as you might have seen in the slide that I pointed out, was over 10 years to have not only the incentives, broken out by market sector. There was a separate program for new construction, residential, small scale, a separate one for commercial and the retrofit. And to bolster along that was this research program that was also funded, which, you're putting out so much solar and, electrifying the grid for the effective grid adoption of it. So not just pushing the incentives and the program towards the technology, but also handling the research aspect or the infrastructure aspect of getting all that solar on the grid. So there is a lot of analogies from there to, sort of borrow for the heat pump. Water heaters, of course, are a different technology, but given that success of the solar initiative, having that more holistic view and really breaking it down into, which I think the Advanced Water Heating Initiative has already naturally, been built and addressing it that way, like the whole working group focused on grid connectivity and breaking down even the unitary market into the 120, 240 to the, I think that is the kind of approach that is going to, if the solar success has a story to tell, I see good things for the water heating initiative as well.
Mm-hmm. So thanks, Smita. So the next question that is coming in is, I would say, for all the panelists, and feel free to chime in. So Larry is asking that I noticed that homes from the 30s and 40s are generally more energy efficient than than compared to modern buildings. Energy got cheap and we responded. Maybe our energy is too cheap. Does anybody want to take on this, like the cost, like operating costs of energy, and how is that impacting the consumer behavior?
I think Larry's got a fine point. We stress over this question a great deal. I've been working in our field since the 70s, since before the first oil crisis. And so energy today is actually less expensive. A gallon of gasoline costs less in real dollars than it did in 1974. Electricity, I haven't done the comparison, but it wouldn't surprise me if everything effectively costs less in real dollars. And so our perceptions of what a dollar can buy has, is what's driving our decision making. When I first moved to California, I moved to a house that was built in 1978, the first year of energy standards in California. And except for the fact that it had single pane aluminum frame windows, it's not a whole lot worse than the home that I live in now that was built in the 2005 level of standards. It was insulated correctly. All but one section of 2x4 foot section of the walls were actually insulated. How do I know? Took an infrared camera and checked. So I think that, that standard was a good standard. It got built okay. Now, we're combining and confusing things about changing the equipment standards and putting in new equipment. The envelope, the plumbing, the insulation on pipes and in walls almost never gets touched after the building gets built. It happens maybe once in a 50-year window unless something breaks. That stuff, in my opinion, has to take precedence over the equipment efficiencies, which we keep wanting to change. Right? Same with the ends of the hot water system, right?
Yeah, on the similar lines.
Pricing, though. I think if using price as a tool, you run into two major hurdles. One is that a lot of the customers who use the most energy are wealthy and therefore price insensitive and don't care how much their electricity costs. And the other one is that customers at the other end of the scale are poor and you can't charge them any more for energy. So using price as a tool gets to some people, kind of gets to the people in the middle. But this is just my kind of a personal perspective. I can't draw on any research here, but I work for a utility, so I've seen some of this. You need other tools to get to the people at the ends of the spectrum.
So just not to beleaguer that, but just add one more point to it. The whole cost of energy needs to build in that carbon, the cost of carbon. So we've been pricing. So in that multi-pronged approach to the market transformation, I think we also need to be looking at rates and tariffs, especially when it comes to the time of use of energy. So more enhancement of time of use and adding the carbon content to the value of energy is going to make for that change that we want to see in behavior. So that becomes yet another channel to address.
And Matt is bringing up a good point related to that is, so have the panelists looked at progress internationally? So for example, China and European Union sales are like almost double the US sales, and people there live in apartments. So which makes him think that they might have like addressed barriers related to heat pump water heater size and noise. So that's a great suggestion. Anybody wants to add to that?
I'd like to put it out to the audience, in fact, to provide some more examples there. We have a globally distributed audience right now, so this is the perfect forum to get some, case studies or examples from the audience here.
I've looked at some product produced in Europe that the heat pump itself is separable. It's detached from the water heater storage component. That means it can be put in a different place. It may not have to be in exactly the same room. That seems to have some advantages about being able to mitigate noise. and change the energy flows, right? You're not always chilling the room you put the water heater in, for example. And so that seems to be an interesting option. I know a couple of the companies that do that are on the call today. So I think that we should be looking elsewhere to see how they manage this question.
Interesting question from Brooke at Department of Energy. Can you talk more about the implications on equity, specifically related to intersection between water heating and electrification, particularly for large centralized water heating systems? Who wants to take that?
I'll be happy to take that. I'll be happy to take that. So I think the Department of Energy and other large municipal organizations, quasi-governmental organizations, housing organizations have a great opportunity with central systems. So replacing existing central boiler systems in like HUD housing or other, economically challenged housing units with central systems. In fact, if we did that alone, the market share that we would have would be significant. So just kind of, that would be my hope, my vision for how we can provide electrification from a central water heating perspective, let alone other improvements with respect to envelope or HVAC that may be suitable for those building types. But I think these quasi-governmental, municipal, public housing authorities have a great opportunity as these new products are coming to market for central systems to retrofit the existing gas boilers, reduce the greenhouse gases, and provide high-quality utility service to their tenants.
From the unitary side, I just want to mention we've been thinking about equity in terms of how we provide products that will meet that need. One of the outcomes of that is the new 120 volt water heater products that they don't need a new 240 volt circuit to run. You can just plug them into an existing standard electrical outlet in the wall, and they'll operate. So that's designed to reduce the installation cost for a heat pump water heater, especially for low-income customers. But in the context of electrification is the ultimate equity initiative, because nationally in this country and in other countries, we have a whole gas distribution network that is entirely not needed. It's an enormous societal cost to maintain transmission and distribution facilities for natural gas, pipes in the ground that need to be maintained and taken out and replaced. All of that costs money. And who pays that money? Ratepayers. That's everybody, including low-income people. So if we eliminate that duplicative utility network, we accrue enormous societal savings that everybody can benefit from. So water heaters is just one stage in that transformation.
Yeah, and to add to that, I also want to add that air quality is one of the biggest benefits, and California Air Resource Board and also the air quality management districts in California, they are looking at the impacts on the air quality when it comes to electrification. And in fact, they have two regulations that they're working on. By 2025, they are regulating the gas appliances, not just water heating, but specifically for space heating, regulating gas appliances so that they will focus on electrification just from equity perspective. So the next question is from Sean at Southern California Edison. In the commercial HVAC world, recently a voluntary method for field measured HVAC performance was established. Oh, wow. So are there lessons to be learned from HVAC quality installation program experience to try in the water heating world? Who wants to take that? Lessons learned from HVAC installation to hot water programs. Gary, do you want to talk a little bit about that?
It's absolutely a great idea. I think that the technology for monitoring information going, flows of energy and other things going in and out of hot water systems has improved rather dramatically, in large part because we worked so hard on HVAC systems. And as we're talking about the multifamily systems, which tend to be bigger, they're more complex for many cases. Those systems, I think, should come with continuous commissioning. And I think that incentive programs should support that piece of the puzzle so that we get real-time information about performance. I think that as part of it, there should be installation feedback, right? And that we do the watching of the systems very, very carefully for the first 10,000, right? A team doesn't know what they did right or wrong until they build 10 of them. They need information. And so I think that doing something, we should learn from what's been done in HVAC and see how we could adapt the essential ideas for hot water.
Thank you, Gary.
One of the big costs right now for water heater installations is, for water heaters is, Lily, I'm trying to talk to my friends, hold on. One of the big costs for water heaters is the installation cost, right? So we're taking a $1,000 item, but it's costing us like $4,500 to install it in people's homes. Most of that cost is installation. How do we get that cost down? The only way we get that cost down is figure out why it's so expensive. So how are we going to figure out why it's so expensive? We've got to collect data in the field. We've got to know what's being installed, by whom, how, whether it works or not, whether it's being installed up to standards. And so having standard data collection for all those things and sharing between utilities is extremely powerful.
I want to be mindful of the time. We're almost at the end of the session, but we are getting some great questions. I am going to end with the last question about national expansion. Smita, you mentioned about expanding nationally. How do you see that helping with market transformation or increasing the rapid growth?
I mean, the West Coast Initiative for Water Heating, the Water Heating Initiative has, seen so much success as the testament you can see from all the presentations today. I know in the interest of time, I'm just going to keep it short and say that come join us join in terms of funding, in terms of partnering, and the Advanced Water Heating Initiative, and both in the West Coast, any regional efforts, as well as we plan to expand nationally for the larger impact, really. But you see the link for the website, and feel free to reach out to Amrita, I, or any of our panelists here associated with the initiative. And I think I'll stop there.
All right. With that, I would like to thank our panelists. It was a great presentation, some thought-provoking discussion, and thank you all for joining today. Thank you.
Thank you, everyone.
Thank you for the opportunity.